Divide with radicals. How do you divide radicals? What's the purpose?
Make them smaller.
Yeah, I mean, like, so you've got these radicals, and you're going to do this division problem. You're going to see how many times something fits into another. But how do we do that with radicals? Because radicals have their own set of special rules. So here's an example problem of what you would see tonight. You would see radical 7 divided by radical 2. And if we were just doing this problem, 7 divided by 2, we'd stop. Because 7 divided by 2 is a decimal. And I like fractions better, so I'd say this is my answer. It can't be simplified anymore, right? 7 over 2 is as simple as it gets. I mean, even if it was, 77 over 20. I'm going to tell you right here, right now. You can never have a radical in the denominator. It's not allowed. You can never have a radical in the denominator. It doesn't happen. It's not acceptable.
Why?
Because that's radical, your denominator, your bottom of your fraction must always be a rational number. It can never be a radical because that's an irrational number, and those numbers cannot be your base. Because a rational number or an irrational number never ends and never repeats. So I really don't know what it is, right? The square root of 2 is a number that never ends and never repeats. So I really don't know what it is. It's kind of like pi. We have to approximate pi. I have to approximate what radical 2 is. And so therefore it can't be my base. It cannot be my whole. So, 3 easy rules. Are you ready? The first thing you should look to see is, can you simplify the original problem? Maybe you can't. It's been known to happen. Maybe you can't simplify the original problem. Can you simplify 7 over 2? No. I'm done. I can't do this. But maybe you can, and it'll make life easier. After you simplify the original problem, now this is going to be confusing. Write it down and think about it as you write it. You multiply. That's not how you spell multiply. You multiply. There we go. The numerator and the denominator. You're going to multiply the numerator and the denominator by the radical in the denominator. We're going to rewrite that in kid-friendly terms, but that's what it's going to tell you. You multiply the numerator and the denominator by the radical in the denominator. And again, make sure you write that down word for word because that's what's going to be helpful. So what does that mean? It means you're going to times the top and the bottom. Is that what it says? Multiply the numerator and the denominator. Does that mean times the top and the bottom? Yeah. Times the top and the bottom by the radical bottom. Times the top and the bottom by the radical bottom. And then my last step, after I always do this, is to simplify the new fraction. And then we're just going to start practicing. Simplify the original problem. If it's necessary, it may not be necessary. Multiply the numerator and the denominator by the radical in the denominator. That just means multiply the top and the bottom by the radical on the bottom. And then simplify. Ready? Radical 7 divided by radical 2. Isn't that rule that I just told you you can never have a radical in the denominator? Here's a hint. You're going to have to do this at every problem tonight. You can never have a radical in the denominator. So what am I going to do? I'm going to multiply the top. And I'm going to multiply the bottom. And what am I going to multiply them by? The radical in the denominator, which is? So I'm going to multiply by radical 2. And I'm going to multiply by radical 2. Because you guys, a radical times a radical, right? What is another way of writing radical 2 times radical 2? I'm squaring it, right? And when you square something, what's that the opposite of? Square rooting it. I'm getting rid of the square root sign by squaring it. So let's see. What's my new numerator? Radical 14, because 7 times 2 is 14. What's my new denominator? Radical 4. But wait a second. Didn't I just say you can't have a radical in the denominator, and we just did all this work and I still have a radical in the denominator? I mean, I just told you. Look, you can never have a radical in the denominator. So you have to go through these 3 steps. I did it, but I still have a radical. Jacob, what's wrong? I can simplify radical 4. The square root of 4 is really 2. So I did get rid of the radical sign. Can you simplify radical 14? What times what is 14?
7 and 2.
And 7 and 2, those don't simplify, right? So there's my answer. And you're done. No, because this is a radical and this is a non-radical. So they do not simplify together. Let's try another one. Let's do 4 divided by radical 6. What do? I have a radical in the denominator. This is a wrong problem. I'm dividing. What is 4 divided by radical 6? Well, simplify the original problem. Does 4/6 simplify? 4/6 simplifies, but is this 4/6? No, it's not. It's 4 over radical 6. So they can't be simplified. So I'm going to multiply the numerator and the denominator by radical 6. What's my new numerator? Not radical 24. 4 is a coefficient times 1 is 4. And no radical times radical is radical 6. Over radical 36. I still have a radical in the denominator. But it's a perfect square. So I can simplify it. 4 over radical 6 over 6. Perfect. The last step, Jacob is going to get it right. Everybody else is going to be like, oh, thank God I'm done. How come this time I can do 4 over 6? I can simplify that. Over here, I couldn't simplify 14 over 2, but here, Jacob, I can do 4 over 6. Why? Because these two, 4 and 6, are coefficients. Over here, the 14 was a radicand, and the 2 was a coefficient. They're not the same. So I'd get 2 over 3, right? Where does the radical 6 belong? In the numerator. Got a little smushed. Noah.
Just doing the second problem. If you're just multiplying, you just cancel out the denominator and just write down the...
If it's just by itself. I'm going to show you one where you have to be careful with that. Ready to do another one? Radical 11 over 6 radical 3. The steps are simplify the radical. So can anything simplify? Can 11 and 3 simplify? No. 1 and 6, can those simplify? No. All right, so I don't need to simplify. So I take the numerator and denominator and multiply by the bottom denominator. So what am I going to multiply by? Radical 3. Radical 3. Don't bring that 6 along for the party. Your numbers are going to get too big. You only multiply by the bottom radical. So what's my new numerator? Radical 33. Zach, put it away, please.
The thing went away.
What's my new denominator? 6. I didn't show it. Radical 9. Wait a second, I still have a radical in my denominator. It's a perfect square. So I now end up with radical 33 over 6 times 3. What's my final answer? Radical 33 over 18. Can radical 33 over 18 be simplified? How come I don't even need to worry about it? This is a radicand. This is a coefficient. They're not the same. Let's do one with a variable. But that's it. So let's do radical 20 over radical 8x. Now here's a little slight difference. I know it also has a variable. But could this simplify? Yeah, 20 and 8 can simplify. I can simplify them because they're both radicands, right? They're both divisible by 4, and they're both radicands. So I could make this 5 over 2x. I mean, that doesn't solve my problem, but it makes my number smaller and easier to deal with, right? So what's this problem? What's happening here? Multiply by radical 2x, because that's my denominator's radical. So what happens in my numerator? Radical 10x over, you could take it one step further and say 4x squared. Some of you are seeing the pattern that if I do this, I could just rewrite the radicand by itself. Radical 10x over the square root of 4 is 2, and the square root of x squared is... Can this simplify? Why can this not simplify? 10x is a radicand. 2x is a coefficient. They're not like terms. So that would be my final answer.
What if you had like a perfect square in the radical on the top?
Like if you did...
Could you still simplify it even if there wasn't a radical on the bottom?
Yes, so let me come up with one. Let's do radical 4 over 3 radical 16. That's the only way you're going to get it, Joel. And to do that, you can perfect square this already. You can re-simplify that. Does that make sense? So Joel's asking, like, what if you got, like, 5 radical 25 over radical, or over 7, right?
Yeah.
You could still simplify that to 5 times 5 over 7 to make 25 over 7. And then simplify your fraction or leave it improper.